Hello, awesome chemists, and welcome to day 2, balancing equations. So this is an alternate way of balancing equations to what Ms. Scoggins showed you. So I'm going to show you what's called the box method. So the box method is a little different, and it's really helpful for those of y'all who are just kind of having difficulty visualizing what we're supposed to be doing and how to balance an equation. So I'm going to walk through it with you, examples 1 through 4, using the box method. So for the box method, we are going to ignore these steps up here, alright? And I'll step you through each bit. So starting with example 1, what we're going to do for every single time we do this is draw a box for each blank that we see. So we'll draw one box for each blank. Alright, now what I like to do is draw a line down from the arrow, because what this is telling us is that the elements on this side of our line have to equal the same number of those same elements on this side. Alright, so if you have multiple colors, go ahead and get them out, because I find this method works best when you can see the different colors. So we're going to start off here. So here we just have C. How many C's do we have? Well, we've just got one. So in this box, we're going to write 1 C. Okay? Now let's move on to the next box. Here we have O2. So how many O's are we talking about? Well, we're talking about 2 O's. So we are going to draw 2 O's in that box. Now let's move on to the next one. How many C's are over here in CO? Well, we've got 1. And how many O's are in this CO? We also have 1. Alright? So each box represents what is written, and each box talks about each compound or each molecule that we have. Alright, so for every blank we're starting off with just one box, and we are going to put what is next to that blank in the box. So we're done with step 1. Now the next step is to count up. Alright, so how many C's are on this left side of our line? Well, we've got 1. How many are on the right side of the line? We have 1. Awesome. So that means our C's, our carbon, is balanced. Let's check our O's. O's, we have 2 on the left side and only 1 on the right. So do we have the same number of oxygens on each side? No, we don't. Now, what's really nice about this box method is that all you have to do, you have to think of, okay, I have 2 over here, and I have 1 over here. So how many more O's do I need to add on this side to get them equal to each other? We just need 1, right? But the thing is, we're dealing with our coefficients, which means we're changing the entire molecule. So now we're going to draw another box, but instead of just drawing another O, we have to put a whole new box. So everything that's inside that box, we're going to put down here again. So that means not only are we adding another O, but we're also adding another C. Alright, so now let's check. Are the O's balanced? Yes, we have 2 on each side. Are the C's balanced? No, we've got 2 C's on the right and still only 1 C on the left. So again, we're going to draw another box. Do the exact same thing, but we don't want to write the CO, right? We want to write what we're drawing the box for. That's just the C. So when you draw boxes down, they're only going to put in what you put above. Okay? So now let's count. How many C's do we have? 2 on the left and 2 on the right. Okay? How many O's do we have? 2 on the left and 2 on the right. So that means our equation is now balanced. Now all we have to do is in the blank, put how many boxes we drew for each one. So we have 2 boxes, so that means a 2 is going to go in the blank. Alright, here we have one box, so we're just going to put a 1 in the blank. And here we have 2 boxes, so a 2 goes in the blank. Alright, so let's try the next one. Here, for example 2, now we're talking about polyatomic ions. So how y'all are going to do it in this class, that y'all are going to keep your polyatomic ion together. You're not going to break it up into individual elements. Because if you look, CO3 is over here, and CO3 is over here. This CO3 doesn't get broken up. It stays together in its polyatomic ion. So when we write our boxes, that CO3 is going to stay together. So, step 1, draw a box for each blank. I would recommend that the larger the compound, the larger the box that you draw. Alright. So, how many Ag do I have? 1. Alright. How many I's do I have? 1. Okay. Over here, how many Fe's are there? Well, we have 2. Fe, Fe. Alright, CO3. I have 3 CO3. So I have to write CO3 3 times, which is why I recommended making a bigger box. Mine still wasn't quite big enough, but that's alright. Now, the important thing, right, is that the color that we used for each element stays the same on each side. So, iron, we use this light blue. How many iron do we have? 1. Okay? How many iodine do we have? Well, we have 3. Okay? Now let's look. How many silver? We have 2. And how many CO3? We have 1. Alright? So, you can pick just about anywhere. What I'm going to do is I'm going to start with the iodine. Okay? So, I have 1 I over here and 3 I over here. So automatically I know that I need to add at least 1 more box over here. So I'm going to do that. And remember, everything in the box. Okay, now I have 2 I's and 3 I's. Well, I don't want to do that, right? I need 1 more I over here. Alright, so now let's see. I have 3 I's and I have 3 I's. So we're good there. Okay, let's check silver. I have 1, 2, 3 over here. I have 1, 2 over here. Okay, so 3 and 2, are they equal to each other? No. So we're going to have to add another box. On the side it has fewer AGs, which is this side. Now remember, we have to create the whole box again. So AG, AG, CO3. Alright, so now I have 4 AG. How many AG do I have over here? Just 3. So we gotta draw another box. Now I know what you may be thinking. This seems very time consuming. And it can be. You don't have to, once you get the hang of it, you don't have to write out everything like I do. You don't have to switch colors. But for the first few times that you do it, I do want you to do this. Because it's going to help you visualize and get in the habit. Alright? So, let's count. 4 AG, 4 AG. Awesome! So, now let's look over here. We have 4I and 3I. That's not right. So, let's do another. Fe, and then 3I. Okay? So now how many I's do I have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That's not right. I know that I need 2 more boxes because 6 minus 4 is 2. I'm going to draw 2 more boxes. Alright, so now I have 6 boxes and 6 eyes. Here I have 2 boxes and 6 eyes. So our eyes are balanced. Let's check our AG again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Well, I need another box. Okay, and now I have 6 AG on each side. Let's check our irons. 1, 2, 1, 2. That's balanced. Okay, let's check the CO3. 1, 2, 3. 1, 2, 3. So hey, look at that. We just balanced that equation. So now, just like before, we're going to write the number of boxes that we drew as our coefficient. So 1, 2, 3, 4, 5, 6. 1, 2, and 3. So it may seem a little time consuming, like I said, but it gets you the right answer. As long as you count your atoms correctly, you are for sure going to get the right answer using this method. Alright? Let's move on to example 3. I'm going to draw my line and my boxes. Okay. So, iron. We have 1. Use this blue. Now, you don't have to keep your colors the same between problems because that doesn't matter. It only matters within the problem that you keep your elements the same color. Alright? So silver, I'm going to make this blue, and nitrate, NO3 is together. It's a polyatomic ion. So we're going to write 1 NO3. Okay, let's check over here. Now, how many iron? Well, we have just 1. How many NO3 do we have? We have 2. So we're going to write NO3 twice. Alright, and silver, we have 1. So our baseline is there. Now we can add as we need to. Okay, iron, 1 on each side, we're good there. Silver, 1 on each side, all good. Nitrate, 1, 2. That's not balanced. We have 2 on this side, 1 on this side, so where are we going to need to add a box? Yep, on the left. Fantastic. So, the whole box. Alright, so now we have 2 NO3, 2 NO3. Awesome. What about silver? We have 2 silver. Oh, just 1 silver over here, so we add another box. Okay, so still 2 nitrate, 2 silver, and 1 iron. Now we're done. That one was pretty easy, right? Write our coefficient as the number of boxes we drew, and we're done with this one. Last one. All right. So example 4. Draw the line and draw a box for each one. Alright. Calcium, we have 1. And SO4, we have 1. SO4 is sulfate. That is a polyatomic ion, so we keep it together. Alright, now let's move on. B, we have 1 boron. And we have 3 hydroxides. That's polyatomic ion, so it stays together. So we write OH 3 times. Now we're over here. Boron, we have 2. Sulfate, we have 3. My boxes are a little cramped because I don't have a whole bunch of space down here. But the more space, the better you can space out your boxes. Alright, calcium, we have 1, And hydroxide, we have 2. Alright. Calcium is balanced. Let's check the sulfate. 1, 3. That's not right. We need 2 more boxes on this side, right? 1, 2, 3. Alright. So the whole box, just like we've been doing, everything in it. Okay, so now we have 3 sulfates on each side. Let's check back to our calcium. We have 1, 2, 3, just 1. That's not right. So let's add another and another to get our 3 calciums. But we also have to add 2 OH in each box. Alright, so calciums and sulfates, they're balanced. Let's check with these OHs that we messed with. 1, 2, 3, 4, 5, 6. 1, 2, 3. Alright, it's not balanced. Let's draw another box. Everything in the box. Okay, so now we have 1, 2, 3, 4, 5, 6 OH. 1, 2, 3, 4, 5, 6 OH. And our borons, 1, 2, 1, 2. Double back, make sure that the calciums and the sulfates are the same. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Looks like everything is balanced, so our coefficient becomes the number of boxes. And we're done. So this is just an alternate method to the table or the chart that Miss Scoggin made a video on. So you can use either method, whatever one works best for you. If you have questions about this, please feel free to see me. I am happy to explain it more. But otherwise, I hope you have a great rest of your day.